All right. Good afternoon or good evening, everybody. This is your host, Maestro Olivares. We're going to get started with Unit 6, Lesson 4, Fitting a Line to Data. Now, I just want to let you know right now, I just cooked the best asparagus that I've ever had, okay? It is pretty darn amazing. Food Max has them for $1.50 a pound. All you got to do is, obviously cut the bottom portions out because those are very stringy. But you cut them in half. You drizzle some olive oil, maybe some salt and pepper. Ooh, they're amazing. Oh my God. After this video, I'm going to go kill another pound of asparagus. It's that good, okay? So, anyways, let's get started. So 4.1, predict this. Here's a scatter plot that shows weights and fuel efficiencies of 20 different types of cars. If a car weighs 1,750 kilograms, would you expect its fuel efficiency to be closer to 22 mpgs or 28 miles per gallon? So let's look at 1750. It's right here. Ooh. It seems to be around there. So we're being tasked to think whether, oh my God, whether it's 22 mpgs or 28 mpgs. 28 is over here, and 22 is here. So it makes sense that it's closer to 22 mpgs. But you might be wondering why. Let me show you why. Remember, you're trying to, or actually, let me just delete all of this. I can erase highlighter. If we erase all of that, you're trying to create a line that represents this data. Watch this. Okay? That's the line. And it makes sense that it's a lot closer to 22 than it is to 28. Especially if it weighs 1750. Okay? Let's go back to 1 and let's use purple. Here's a table that shows weights and prices of 20 different diamonds. So if you didn't know, diamonds are weighed using carats. I don't know why. You have the actual price of how much they cost, but then you have the predicted price. Now you might be wondering, how are they predicting this? Well, if we go back to the previous example, that green line, you can actually find an equation for that green line, right? You have your starting value, you can find your slope, and then bam, you have an equation that can predict the line. So it sounds like for this one, they plotted or graphed all of these points, they found the equation, and then they used that equation to predict the price. No. Okay? So some of these are obviously overestimated, right? Like this one, this one, this one. And some of these are actually underestimated. Okay? So, the scatter plot shows the prices and weights of 20 diamonds together with the graph. See, there's your equation. The function described by the equation is a model, of the relationship between a diamond's weight and its price. So it makes sense that the more carats it has, the more costly it is. Now, if you're like me, there's no need to be buying a $10,000 ring. Just go to the flea market. You'll find one for like $10. This model predicts the price of a diamond from its weight. These predicted prices are shown in the third column. And that's this one up here. That one. Two diamonds that both weigh 1.5 carats have different prices. What are their prices? How can you see this in the table? Well, here's the table. 1.5 carats. Here are their prices. I wonder if you can copy. I don't know how to do that. How can you see this in the graph? Well, you can see it in the table by looking at the values. on the graph, you look where 1.5 is right here. And then you have one of the prices, and you have another price here. And then this line, that's the predicted value, okay? See graph. The model predicts that when the weight is 1.5 carats, the price will be $7,189. How can you see this in the graph? How can you see this using the equation? Well, in the graph, here I'll use the blue marker and then I'll minimize this. It's right here. Right? Because that's where, oh, that's pretty small. That's where it's 1.5 carats and it crosses the line right there. So you can see it in the graph by looking at where the line crosses at x equals 1.5. And then how can you see this using the equation? This is where a lot of you might struggle, but this equation, let me highlight it in yellow, because YOLO, that was horrible, I'm sorry. Oh, wait, what? No, I gotta fix this. Oh, pues. 18? 18. No, 18. There you go. This equation can give you the predicted price, okay? So what we're gonna do is, first of all, we're gonna rewrite the equation. Y equals 5520x minus 1091. Okay? And since it's 1.5 carats, all you gotta do is plug in 1.5 into x. Why did I do that? I have no idea why I did that. No! Those are my buddies hitting me up to play Fortnite. No! Now, I'll be honest, I don't have a calculator. Actually, we can kind of do this. So, 1.5 is the same thing as 1 plus 0.5. 1 times 5520 is 5520. 0.5 is the same thing as 1/2 of 5520. If I were to break apart 5520, I would break it up as 5,520. Half of 5,000 is 2,500. Half of 500 is 250. And then half of 20 is 10. We add those up. I can't speak right now. Up. 5 plus 5 is 10. Plus 2 is 12. Add 1. That's 8. And then we're supposed to subtract 1091. So that's going to be 8280 minus 1091. Oh, I don't like this. Okay. I can't subtract 0 from 1, so I got to borrow from the 8. How does it work? How do you borrow? Oh, I feel so vulnerable. I don't know how to borrow. Okay, you know what? I'm just going to take the L here. I know that 1,091, if I add 909, that equals 2,000. 2,000 take away 8280 is 6,280. So I add these two numbers. Yeah, I mean, you could easily use a calculator and do this a lot easier. 7189. And sure enough, that's what it equals, right? 7189. Yeah. So I apologize. I honestly don't know how to borrow. I'm a math teacher that doesn't know how to borrow. Big. Oof. XD. Do you guys even use that emoticon anymore? One of the diamonds weighs 1.9 carats. What does the model predict for its price? How does that compare to the actual price? Oh, bro. Really? So if we want to find the price, when x equals 1.9, y is going to be 55. Oh my god, why do I keep doing that? 5520 times 1.9 minus 1091. That's going to be equal to the predicted. I want you to do this on a calculator. I'm not going to do it, bro. Okay? And then if you want to find the actual price, you would just go to where 1.9 is. Actually, I'm going to be lazy. I'm going to use this. 1.9, 95.41. That's a lot of money. Actual is, I forgot what the numbers were. 95.41, was it? I don't know. And then how does that compare to the actual price? So you're going to figure out what this equals, and then you're going to compare it. Is it higher? Is it lower? Okay? So find a diamond for which the model makes a very good prediction of the actual price. How can you see this in the table or in the graph? Find a diamond for which the model makes a very good prediction of the actual price. So what they're asking us to do is, find one where it matches. So you're looking for these points right here, okay? The ones that are on the line. Because that means the prediction is very close, or in fact, it is exactly what the actual cost is. And let me look at the x values here. 118, 130, 118. Yeah, you see? 118 or 1.2. That's really close. And this is also really close. Okay? That's how you can tell. And then, no. Find a diamond for which the model's prediction is not very close to the actual price. How can you see this in the graph or in the table? So in the table, you're going to be able to see the difference, right? The difference is going to be really big. And in fact, because I'm a nerd, there should be a fourth column that says residual. And the residual should either be positive or negative. And what the residual is, how you calculate it is actually, it's the predicted minus the actual. And so if it's positive, that means you're overestimating. And if it's negative, you're underestimating. But when the residual is 0, this means the prediction is actually the same thing as the actual cost. I'm surprised y'all are not learning this. Well, then again, I didn't learn this until I was in college. Oh, yeah. So how can you see this from... Oh, okay. So we're looking for something where the residual, right? We're looking where the prediction is off. So we're looking where the residual is really positive or really negative, because that means the line is not predicting it correctly. And if you were to guess, which point is way off the line? I'll give you some think time. Dun, 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 dun. So there's a couple of points I could say. I would probably say this one down here. This one. This one. This one. Maybe this one as well. Those are really off. The agony of the feet. Get it? The agony of the feet. Like the feet. Lamau. Raffle. Copter. Okay, stop. Here is a scatter plot that shows lengths and widths of 20 different left feet. Wait, so you have a foot. That's a foot. That's your big toe. And it's finding the length and the width. Okay. Okay. Estimate the lengths of the longest foot and the shortest foot. Okay. Well, the longest foot is going to be this one. Longest And the shortest is going to be this one right here. Estimate the widths of the widest foot and the narrowest foot. Okay, so I'm gonna use a different color, azul. Oh, again, widest, and this one seems to be the narrowest, right? Because you're looking for the smallest or the biggest value, like this, and then this is like this. Hear it, bro? Jesus. Wait, I should just put my phone on. Do not disturb. You learn something new every day. Here's the same scatter plot with the graph of a model for the relationship. So remember, model just means line for the relationship between foot and width. Circle the data point that seems weird when compared to a model. What length and width does that point represent? So I want you to take 10 minutes to decide. Right, pause the video for 10 minutes and decide which one seems to be outside of the line. Okay, I'm not going to actually have you wait 10 minutes. That's ridiculous. You could do a lot of 10 minutes. You could do like, I don't know, shower in 10 minutes. Some of y'all probably haven't even showered, TBH. I know I have. Anyways, if you pick this point right here, that is the point we're looking for. That's the weird point. Ooh, asparagus sounds really good right now. That's the weird point. Actually, I had some really good pan dulce today. Oh my god. The donuts were literally fresh out of the, I guess, oven. Oh, that thing got destroyed in like 5 seconds. Oh, kind of want another one now. What's the length and the width? Well, the length seems to be about 24.1 centimeters. And the, length. And the width seems to be about 7.5 centimeters. You decide. Okay? You don't have to believe everything I'm saying, by the way. I mean, you should, but, like, question it. Don't believe the media. So, that's actually it for today's lesson. So, really, what today's lesson is, well, let's just read through it. Sometimes we can use a linear function as a model of the relationship between two variables, right? For example, here's a scatter plot that shows heights and weights of 25 puppers together with a graph of linear function with a model blah, 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 blah. Okay? So we can see that the model does a good job of predicting the weight given the height for some dogs. These corresponds to the points on or near the line. Okay? That's all of these right here. The model doesn't do a very good job of predicting the weight given the height of the dog whose points are far from the line. These points right here. For example, there's a dog that's about 20 inches tall and weighs a little more than 16 pounds. The model predicts the weight would be about 48 pounds. We say that the model over-predicts the weight of the dog. Earlier, I was saying the residual is positive, but that's the same thing. There's also a dog that is 27 inches tall and weighs about 110 pounds. God damn, that's a big dog. The model predicts that its weight will be a little less than 80 pounds. We call this a negative residual, or under-predicts. Sometimes a data point that is far from the other points doesn't fit the trend that at all. We call these, and I didn't want to say this word earlier, but now I'm going to say it, outliers. It's actually pronounced outliers, and this is part of your focus area, actually, okay? Outliers. I've been doing this since 96. Anywho, I hope you enjoyed today's lesson. Remember, we're looking at scatter plots and we learned a new word, outliers, okay? So go ahead and be an outlier today or tonight.